In this video, we will be solving problem 18 in chapter 4. First, we need to define the problem. We need to know what we are solving for. The problem states that we need to find some thermal conductivity of this protecting material or this protective layer to maintain the coldest part of the good tissue at 0 degrees Celsius. The problem already gives us a nice schematic to work with. In the schematic we have 3 different layers. We have some tissue that we need to destroy, we have some protecting material, and we have some good tissue that we need to protect. We're also told that the cryoprobe maintains this surface, or in the tissue to be destroyed, at minus 196 degrees Celsius. We can call this the surface at the position x equals 0. We also are told that the far side of the good tissue, or the surface at 4 centimeters, is held at 37 degrees Celsius. The problem also states that the coldest part of the good tissue needs to be maintained at 0 degrees Celsius. Now the question is, where is the coldest part of the good tissue? We know the good tissue start layer is here, and we also know that the cryoprobe is located at this position at x equals 0. Hence heat is being lost directly through this surface. So it only makes sense that the coldest part of the good tissue is the surface closest to the cryoprobe, or this surface here at 2 centimeters. So we can include in our schematic that this surface is held at 0 degrees Celsius. Lastly, we are given the thermal conductivity of the frozen layer as 2 watts per meter Kelvin, and the thermal conductivity of the unfrozen layer as 0.552 watts per meter Kelvin. Now we need to talk about any assumptions we need to make to solve this problem. The problem states that we are at some steady state, so a steady state analysis for this problem is appropriate. We also need to assume that no heat is lost in any other directions other than the x direction. So we will be doing a 1D analysis for this problem.